Everyone's talking about how fast AI is getting, but nobody's talking about the brick wall it's about to hit at 100 miles per hour. We aren't running out of code. We're running out of electricity. Here's the terrifying reality. By 2030, data centers are set to double their global electricity consumption. Right now, a single high-end AI chip consumes as much power as an entire American household. We are physically running out of juice to power the future. But what if I told you that Google just found a backdoor in physics? A way to break the rules of energy consumption that could save the entire AI industry from collapsing under its own weight? This isn't science fiction for 2050. This happened this year. And the company that might actually win this race isn't Google. It's the one huge player you stopped paying attention to. Let's get technical for a second, because the nuance matters. Google Quantum AI just achieved 2 milestones that essentially turned the lights on for the entire industry. First, they demonstrated their first logical qubit prototype. Why does this matter? Because until now, quantum computers were noisy, error-prone messes. A physical qubit is unstable. If you look at it wrong, it fails. A logical qubit is error-corrected. It's reliable. It works. Google basically just proved they can build a stable engine, not just a concept car. Their roadmap now points to 1 million qubits in the next few years. To put that in perspective, going from where we are now to 1 million qubits is like trading in a pocket calculator for a supercomputer overnight. But speed isn't the real story here. Energy is. This is where your brain might break a little, but stay with me. There is a fundamental law of physics called Landauer's principle. It dictates that every time a classical computer, like your laptop or an NVIDIA H100, erases a bit of information, it must release a specific amount of energy as heat. Classical computers are constantly erasing and rewriting billions of bits. That is why data centers need cooling towers the size of skyscrapers. They are fighting physics. Quantum computers work differently. They are reversible. Instead of erasing data, they can uncompute it. Because they don't erase, they don't generate that mandatory waste heat. This means for complex problems, a quantum computer isn't just faster. It is exponentially more energy efficient. It's a cheat code for thermodynamics. However, there is a catch that the headlines are ignoring. Not all quantum computers are created equal. Google is betting on superconducting quantum computers. The problem? They need to operate at temperatures near absolute zero. We are talking about massive dilution refrigerators that consume around 25 kilowatts of power just to keep the chip cold. You are spending 99% of your energy on the fridge, not the math. Compare that to neutral atom quantum computers. They can operate at room temperature. Same processing power, but they only burn about 10 kilowatts. That is instantly a 3 times efficiency gain. This is the hidden war happening right now. It is not just about who has the most qubits. It's about who can run them without needing a nuclear power plant next door. And this is where the dark horse enters the race. While everyone was watching Google, Microsoft dropped a bombshell in February 2025. They introduced the Majorana 1 quantum chip. This is a completely different architecture based on topological superconductor materials. That sounds like buzzword soup. But here's the claim that should scare Google. Microsoft says, they can fit over 1 million qubits on a chip the size of your palm. If, and it is a massive if, this works, Microsoft leapfrogs everyone. No massive room-sized fridges, no energy crisis. Just a palm-sized chip that outperforms the world's combined supercomputers. If Google is building the fastest race car, Microsoft is trying to invent teleportation. Why does this matter to you? Because we aren't just talking about faster chatbots. We are talking about solving problems that are mathematically impossible for classical computers. Take material science. We are currently stuck trying to invent better batteries and hydrogen membranes by trial and error because classical computers physically cannot simulate the molecular complexity of these materials. A quantum computer can. We could see a revolution in battery density, fertilizer production, and carbon capture materials within this decade. And for the energy grid itself? Quantum algorithms can optimize wind farms and traffic flows in real time, saving gigawatts of wasted power. The energy needed to run the quantum computer is a rounding error compared to the energy it saves the world. Don't forget the other players. You have IonQ currently sitting at an $18 billion market cap using a trapped ion architecture. They are using individual atoms as building blocks. They aren't profitable yet, but their approach is incredibly diversified. Here is the investment thesis for the 2020s. The difference in power demand between these architectures. Superconducting versus neutral atom versus topological could be up to 100 times. That is 2 orders of magnitude. Governments and trillion-dollar industries are going to pick the winner based on that efficiency number. We are looking at a winner-take-all scenario. The company that solves the qubit scale problem and the energy problem simultaneously will become the most valuable company on Earth. Let's talk about the next 3 years. The years 2026, 2027, and 2028 are the window. This is not a someday technology anymore. Google has proved the physics works. Microsoft has claimed the scaling works. IonQ is proving the market exists. The convergence of AI's hunger for power and quantum's ability to provide. It is the biggest investment opportunity of our lifetime. If you are in tech, start learning quantum principles now. If you are an investor, look for efficiency, not just speed. We are witnessing a phase shift in human capability. The age of quantum abundance is coming fast. The only question is, will you be ready for the shift? Or will you be left using a calculator in a supercomputer world? Thanks for watching. If this blew your mind, hit that subscribe button for more deep dives into the tech that's shaping our future.